Pop quiz. What's the worst way to die in space? You might say running out of oxygen, suffocating in the void while you desperately claw at your helmet. Terrifying, sure. Unlike. Maybe you'd say freezing to death. Your body temperature drops, you get sleepy, you drift off into eternal cold. Poetic, even. Unlike. Or perhaps burning up during atmospheric re-entry. Your spacecraft fails, you plummet back to Earth, and you become a shooting star made of regret. But at least it's quick. Unlike all of these deaths, there's one way to die in space that's so horrifying, so physically impossible to comprehend, that physicists had to invent new words to describe it. Falling into a black hole. And I'm not talking about the Hollywood version where you dramatically disappear into darkness. I'm talking about what actually happens according to physics. Spoiler alert, you get spaghettified. Yes, that's the real scientific term.
And yes, it's exactly as bad as it sounds.
But here's the thing that's going to ruin your day. The way you experience falling into a black hole is completely different from how someone watching you experiences it. To you, it takes seconds. To them, it takes forever. Time breaks, space breaks, physics breaks, you break. And depending on which physicist you ask, you might die 3 different ways simultaneously. Welcome to the most disturbing thought experiment in astrophysics. If you want more videos about the universe trying to murder you in creative ways, smash that like button and subscribe. Because space is terrifying, and I have so many more ways to ruin your sense of cosmic safety. This is a space teleporter. Blah, 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 we're going to the edge of a black hole. We've done this journey before. Let's go find out exactly how the universe plans to kill you. Historically, well, actually, Astrophysically Facts, Part 1. Before we talk about falling into a black hole, we need to establish what a black hole actually is. Because you think you know, but the reality is so much weirder. A black hole is not a hole. It's not a tunnel. It's not a vacuum cleaner in space. It's a point. A singularity. A place where gravity is so strong that the fabric of space-time itself collapses inward. It's what happens when you compress enough mass into a small enough space that escape velocity exceeds the speed of light. Here's the simple version. Escape velocity is how fast you need to go to escape a gravitational field. On Earth, it's about 11 kilometers per second. On the Sun, it's 618 kilometers per second. On a black hole, it's faster than light. And since nothing can travel faster than light, nothing escapes. Not matter, not energy, not even light itself. Hence the name, black hole. The universe's ultimate roach motel. Things check in, they don't check out. But here's what they don't tell you. Black holes aren't just strong gravity. They warp space-time so severely that the normal rules stop working. Inside a black hole, time becomes space and space becomes time. The singularity isn't a place you go to, it's a moment in your future that you cannot avoid. Once you cross the event horizon, the point of no return, falling into the singularity isn't a choice, it's as inevitable as tomorrow. You can't stop falling toward the singularity any more than you can stop moving forward in time. Because in that region of space-time, inward is the only direction time goes. Your brain is already hurting. Good. It gets worse. The event horizon. Let's talk about the event horizon. This is the boundary of the black hole, the point where escape velocity equals the speed of light. Cross this line, and you're done. No coming back, no second chances. The universe has deleted your save file. But here's the trippy part. From your perspective, crossing the event horizon is completely unremarkable. You don't feel anything special. There's no wall, no barrier, no warning sign that says, quote, 0. You just smoothly pass through an invisible boundary in space, and your fate is sealed. But from an outside observer's perspective, they never see you cross. Ever. To someone watching from a safe distance, you appear to slow down as you approach the event horizon. Your movement gets slower and slower. Time dilation kicks in. From their perspective, time is passing normally for them, but incredibly slowly for you. You reach the event horizon and you just freeze there, forever. Your image gets dimmer and redder as photons struggle to escape the gravity well, but you never disappear. You're stuck at the boundary, frozen in time, for eternity. So which is real? Do you cross the horizon or don't you? Both. You experience crossing in finite time. They experience you never crossing in infinite time. This is relativity. Time is not universal. Your timeline and their timeline diverge at the event horizon. You're living in a different temporal reality. And this is before anything bad has happened to you. Now, you might think, okay, so I'm frozen from their perspective, but I keep going from mine. That's weird, but fine. Not fine. Because here's what happens next. Tidal forces, spaghettification, the stretching. Spaghettification is not a metaphor. Let's talk about tides. On Earth, tides are caused by the moon's gravity pulling on the oceans. The side of Earth closest to the moon experiences stronger gravity than the far side. This difference in gravitational force is called a tidal force. It's gentle, it moves water around, no big deal. Now scale that up to black hole levels. The gravitational force at your feet, which are closer to the black hole, is significantly stronger than the gravitational force at your head. This difference is not gentle, it's extreme. Your feet are being pulled thousands of times harder than your head, so you stretch violently. This is spaghettification. The scientific term is tidal disruption, but physicists call it spaghettification because it's literally turning you into spaghetti. Your body stretches longer and thinner. Your bones elongate. Your muscles tear. Your blood vessels rupture. Your spine extends beyond any possible limit. You become a long, thin string of atoms, stretched across space like cosmic taffy. And it's not just vertical stretching. You also get compressed horizontally. The gravity is pulling you toward a single point, so while you're stretching head to toe, you're also being squeezed from the sides. You're becoming longer, thinner, and more cylindrical. You are being extruded through space like meat through a grinder. Imagine being pulled apart and crushed simultaneously. Now imagine that happening at the molecular level. Every cell in your body is experiencing this. Every atom. At what point do you die during spaghettification? Great question. Probably pretty early. The moment the tidal forces exceed what your cellular structure can handle, you're done. Your neurons can't fire if they're being stretched. Your heart can't pump if it's being compressed. You lose consciousness fast. Then your body continues stretching without you, which is honestly a mercy. By the time you reach the event horizon of a stellar mass black hole, you're not a person anymore. You're a stream of atoms arranged in a vaguely U-shaped pattern, scattered across thousands of kilometers. But here's the really messed up part. The smaller the black hole, the worse the spaghettification. A stellar mass black hole, formed from a collapsed star, has an event horizon only a few kilometers across. The tidal forces near it are insane. You'd be ripped apart long before crossing the horizon. But a supermassive black hole, the kind at the center of galaxies, has an event horizon millions of kilometers across. The tidal forces are much gentler. You could theoretically cross the event horizon of a supermassive black hole without even noticing. You'd survive the crossing, you'd live for a little while inside the black hole, completely unaware that you're doomed, until you get closer to the singularity, and then the tidal forces kill you anyway. So your survival time depends on the size of the black hole. Small black hole, dead before you enter. Large black hole, dead after you enter. Either way, dead. The universe is just deciding how long to wait before killing you. What you see while falling. Okay, let's say you're falling into a supermassive black hole and you somehow survive crossing the event horizon. What do you see? This is where physics gets beautiful and terrifying. Because of time dilation and gravitational lensing, your view of the universe becomes extremely weird. First, gravitational lensing. The black hole's gravity bends light around it. As you fall, you can see light from behind the black hole being bent around it. You see distorted, multiple images of stars. The entire sky warps and curves. Straight lines don't exist anymore. Everything is bent by gravity. If you look back the way you came, you see the entire future history of the universe compressed into a shrinking circle of light. Galaxies age, stars die. Time passes faster and faster in that direction. But if you look toward the singularity, you see darkness. Not because there's no light, but because any light that enters the black hole with you is also falling toward the singularity. It can't reach your eyes from in front of you. It's all being pulled downward faster than it can travel outward to you. So ahead of you, darkness. Behind you, the universe in fast forward. You're falling through a tunnel of space-time where past and future are visible simultaneously in different directions. And then there's the radiation. Hawking radiation, if the black hole is small enough and old enough, quantum effects at the event horizon cause particle-antiparticle pairs to form, and sometimes one falls in while the other escapes. To you, falling in, this might look like a faint glow, a firewall of radiation. Some physicists think this firewall would be so intense it would incinerate you instantly at the event horizon. Others think it's too weak to matter. They're still arguing about it. You're dead either way, but the method is under debate. You might also see the ghosts of everything that ever fell into the black hole before you. Information gets scrambled at the event horizon. Some theories suggest this information gets encoded on the surface, like a hologram. So you might see fragments, echoes, scrambled data from every previous victim. Astronauts, planets, stars, all compressed into a two-dimensional information smear on the event horizon. You're about to join them. Your entire existence will be reduced to quantum information on a spherical surface. You will become data, encoded, stored, forever. The 3 ways you die. Now we get to the truly disturbing part. Physicists can't agree on exactly how you die in a black hole. There are multiple competing theories, and depending on which one is correct, you die in completely different ways. Let's go through them. Death number 1. Spaghettification. We covered this. Tidal forces rip you apart. Classic. This definitely happens eventually, no matter what. As you approach the singularity, tidal forces become infinite. You stretch until your atoms are pulled apart into subatomic particles, and then those particles are pulled apart into energy. You dissolve into the fabric of space-time. This is the standard death, the expected death, boring almost. Death number 2, the firewall. This is the controversial one. Some physicists argue that quantum effects at the event horizon create a wall of high-energy radiation. Cross the horizon, you hit the firewall, you're instantly incinerated, your atoms are blasted apart by quantum energy. You don't get spaghettified because you never make it past the event horizon. You burn up on contact. This theory is hotly debated. If it's true, the event horizon is not a smooth, crossable boundary. It's a barrier of fire, a quantum furnace, and your fuel. Death number 3, the information paradox. This one is existential. Quantum mechanics says information cannot be destroyed, but black holes destroy information by trapping it inside where it can never escape. This creates a paradox. Physicists have proposed various solutions, one of which is that you don't actually fall in. Instead, you're copied. Your quantum information is encoded on the event horizon, while a copy of you continues to fall toward the singularity. So you die twice, once as a hologram on the surface, your information scrambled and stored, and once as a 3-dimensional being inside the black hole, spaghettified into oblivion. 2 deaths, 2 versions of you, both dead. Which one is real? Nobody knows. Physicists are still arguing. You might get spaghettified. You might get incinerated. You might get quantum copied and die twice. Or maybe all 3 happen simultaneously in different reference frames. Schrödinger's death. You're alive and dead and also dead again until someone observes you, except no one can observe you because you're inside a black hole. The universe is gaslighting your corpse. The singularity. Let's say you somehow survive everything so far. The event horizon, the firewall if it exists, the initial spaghettification. You're still falling. And ahead of you, at the center of the black hole, is the singularity. This is where all the mass of the black hole is concentrated. Infinite density, infinite gravity, a point of 0 volume containing potentially millions of solar masses. Physics doesn't work here. Math breaks down. General relativity predicts a singularity, then throws up its hands and says, I don't know what happens next. Some physicists think the singularity is a point. Others think it's a ring, especially if the black hole is rotating. Some think it's not really infinite, just incredibly dense, and that quantum effects we don't understand prevent true infinity. Nobody knows. We've never observed one. We can't observe one. The event horizon blocks all information from escaping. The singularity is hidden behind an impenetrable wall of space-time. It's censored by the universe itself. Cosmic censorship. That's the actual term. But let's assume you reach it.
You're now at a point where the curvature of space-time is infinite. Time and space have completely swapped roles. You can move freely in time, but you're being dragged inevitably through space toward the singularity. Inward has become your future. The singularity is not a place you can avoid going to. It's a when. It's tomorrow. It's happening. You're being pulled into it not by force, but by the structure of space-time itself. And then you hit it. Or rather, you become it. Your atoms, your energy, everything you are gets absorbed into the singularity. You're compressed into a point of infinite density. Do you still exist? As what? Energy? Information? A mathematical abstraction? Nobody knows. You've reached the edge of human understanding. Past this point, there are only equations that don't make sense and physicists having existential crises. Some theories suggest you might emerge from a white hole on the other side. A white hole is the theoretical opposite of a black hole. Instead of everything falling in, everything explodes out. But there's no evidence white holes exist. It's mathematical speculation. You probably don't emerge anywhere. You probably just end. Compressed into the singularity, erased from existence, converted into gravitational energy. Your atoms, which were forged in stars billions of years ago, are now part of a black hole's mass. You have returned to the universe in the most violent way possible. The time dilation nightmare. We need to go back to the observer problem, because this is where it gets psychologically horrifying. Remember, to someone watching from outside, you never cross the event horizon. You slow down, you freeze, you fade, but you never disappear. From their perspective, you're always there, hovering at the boundary, getting dimmer and redder, but never gone. Now think about what this means. If you fell into a black hole today and your friend watched from a safe distance, they would see you frozen at the event horizon. Tomorrow, they look, you're still there. A year later, still there. A million years later, still there. Your frozen image persists. As far as the external universe is concerned, you're stuck at the moment of crossing forever. You're a ghost haunting the event horizon for all eternity. But from your perspective, you crossed instantly and died seconds later. So which timeline is real? Both. You're simultaneously frozen forever and long dead. This is the relativity nightmare. There is no universal now. Your now and their now are different. You're living in separate temporal realities. You died in your timeline. You're frozen in theirs. Both are true. And here's the really disturbing part. Because of time dilation, the outside universe is aging rapidly from your perspective. If you could look back as you fall, you'd see stars dying and fast forward, galaxies colliding, the universe aging billions of years in what feels like seconds to you. You're watching the heat death of the universe in real time while you fall to your doom. The last thing you see before you die is the end of everything. So you don't just die. You die while watching the universe die. You're both ending together. You're experiencing your personal apocalypse while witnessing the cosmic one. It's almost poetic. Almost. Mostly it's just horrifying. The black hole information paradox. We need to talk about the information paradox because it's the problem that's been haunting physicists for decades. Quantum mechanics says information is conserved. It cannot be destroyed. It can be scrambled, hidden, transformed, but not destroyed. But black holes seem to destroy information. Everything that falls in is lost forever. This violates quantum mechanics. Paradox. Stephen Hawking spent years working on this. He eventually proposed that information isn't destroyed. It's encoded on the event horizon as a hologram, then slowly released through Hawking radiation as the black hole evaporates. Black holes aren't permanent. They leak energy over time and eventually disappear. When they do, all the information they contained is released back into the universe, scrambled beyond recognition, but technically still there. So you're not destroyed, you're encrypted. Your quantum information is stored, then broadcast back into space as random radiation billions of years later. This is somehow more disturbing than just dying. You don't cease to exist. You're converted into information stored on a two-dimensional surface, then slowly radiated back out as noise. Your consciousness, your memories, everything you are becomes static. Random fluctuations in a quantum field. And technically, all the information needed to reconstruct you still exists in that radiation.
It's just scrambled so thoroughly that reconstructing you would require calculating the quantum state of every particle in the black hole's radiation field. Impossible with any conceivable technology. So you're dead, but also technically recoverable, but also practically irrecoverable. Schrödinger's corpse strikes again. You exist as a probability cloud of quantum information smeared across space-time. This is your afterlife, your data, haunting the universe as noise. So here we are. You wanted to know what happens if you fall into a black hole. Now you know. You get spaghettified, or incinerated, or quantum copied, or all three. Time breaks, space breaks. You stretch into a string of atoms. You watch the universe age and die while you fall. You cross an event horizon you can never uncross. You become information encoded on a surface. You eventually get radiated back out as noise. And from the outside universe's perspective, you never even fell in. You're frozen at the boundary forever. The worst part? None of this is speculation. This is what general relativity and quantum mechanics predict. These are the equations. This is real physics. If you fell into a black hole, this would actually happen to you. It's not a thought experiment. It's a prediction. The universe has these things, these monsters, these tears in space-time that will absolutely do this to you if you get too close. Black holes are nature's nightmare machines. They're proof that the universe can create pockets of reality so extreme that the normal rules stop working. They're places where time becomes space, where futures become inevitable, where information becomes noise, and where you become spaghetti. They're not just dangerous, they're existentially horrifying. They don't just kill you, they unmake you. They break you down into components, scramble the components, store you as data, then forget where they put you. And the universe is full of them. Millions of stellar mass black holes scattered throughout galaxies, supermassive black holes at the center of every major galaxy, including ours. They're everywhere. Right now, there's a black hole 26,000 light-years away at the center of the Milky Way, Sagittarius A star, 4 million times the mass of the Sun, sitting there, waiting. And if you flew directly toward it, this entire nightmare would happen to you. The universe has given you a very detailed instruction manual on exactly how it plans to kill you if you're dumb enough to try. So maybe don't fall into a black hole. Just a thought. Just some friendly advice from physics. The universe is scary enough without voluntarily subjecting yourself to spaghettification. There are better ways to experience time dilation. Like watching a Christopher Nolan movie. Same confusion, less death.